Okay, good afternoon and welcome to the 8th session of the 2020 Sunoikisis Digital Classics semester. This is the second of two sessions on tree banking. 2 weeks ago, you heard a session with Vanessa Gorman and Helena Jordanova on how to create morphosyntactic annotations. And this week, we're joined by Francesco Mambrini and Toon van Hal, who are going to talk to us about using treebanks, querying and using them in research. We're also joined by Alec Kesmakers, who is responsible for some of the work that we'll be looking at today. So he'll join us for discussion as well. So hi, and thanks to all of you for joining us. And I believe Francesco is starting off.
Hi everyone, and hi Gabby, and thank you very much for having me here for this Sunoikisis session on tree banking. My name is Francesco Mambrini. I'm a researcher at the Università Cattolica del Sacro Cuore in Milan, Italy, and I've worked with tree banks since my my postdoctoral years, so since a decade more or less right now. And okay, let me just start with my slides. Is everything fine? Can you see my slides?
Well yes, enough? That's great. Yep.
Perfect. Good. So this session is dedicated, as Gabby said, to using tree banks and doing some, taking the first step, as much as I am concerned, taking the first steps toward these fantastic visualizations and research experiments that Vanessa Gorman already presented at the end of the first sessions about the tree banking. So here's the outline of the session in general. I will give a general introduction right now on the application of tree banks, so an overview of what you do with tree banks, and in particular I will focus on how to do the work that I've been trying to do this last year, so doing linguistic or textual research, and that involves the task of querying, extracting information from tree banks, so using some sort of formalized language to extract knowledge from the annotation that somebody has put into a digital format, syntactic annotation of the tree banks. Then Professor Toon van Hal will talk about later on about another type of application of tree bank. So using tree bank to build natural language processing applications, and so how to produce new annotation. This is very, very interesting and fascinating. Then I will also give some example of performing queries on tree banks using one specific tool. So to be clear and to just repeat what has already been said, but so that everyone has a fresh memory of what a tree bank is. A tree bank is a linguistically annotated corpus, so it's a collection of text with some linguistic annotation, which is stored in digital format. So which linguistic annotation? Well, can be a lot of things, but in order to have a tree bank, you must at least have 2 levels of annotation. Morphology. Sometimes in modern the tree banks, you see just the part of speech. So if a word is a noun, an adjective, a pronoun, or a verb. But in case of ancient languages like Greek and Latin, you have most of the time full morphological feature. So not just that a word is a verb, but what mood, what tense, etc., etc. And then you also have a representation of the syntactic structure of the sentence. Now, an important thing to remember about tree banks is that there are a lot of them, actually. The last session, you saw one of the tool to produce a tree bank using one type, one standard, and one annotation style that annotates some syntactical structure, like a coordination in a specific way, or relative sentences in a sort of way. But keep in mind that there are a few. I will tell you more about that in a second. And then also that it's not just a thing that we, the crazy classicists do for fun. It's something that's been available for a while right now for computational linguistics for a lot of languages. And it started off with annotations of the Wall Street Journal. so nothing to do with classics. And right now there are Treebanks covering several languaging and several modalities. There are Treebanks that analyze tweets or chat corpora or something like that. So I'll start with some autobiographical node, what I did with them, so to give you an idea of what type of research you can do with them. So what did I use Treebanks to study? What was the subject that I studied using Treebanks? I started by doing some work on the nightmare of every student of Greek and Latin. So those discontinuous phrases where you start off with a noun, you put something that has nothing between, that has nothing to do with that noun, and then you get an adjective that goes back to that noun, and you build a word order nightmare for students. But this is actually a construction that is very frequent in ancient languages, and for a reason. It's not just random, like some students sometimes like to complain. Then I also used Treebank to study. And what did I want to do with this type of study? Well, I wanted to measure how frequent it was, and it turned out that it was actually pretty frequent. More frequent. This type of construction is more frequent in the Treebank of ancient Greek than it is in other Treebanks, as I mentioned before, dealing with other type of languages or other type of media and genres of text. Then I looked to agreement patterns with coordinated subjects. You might know, or you might not, that in Greek and a little less so in Latin, whenever you have coordinated subjects like John and Peter, they can trigger singular or plural agreement with the verb. So the verb can be either run or runs. In singular, and this was particularly interesting and instructive even from a methodological point of view. And so the results of this study is one of your seminar reading, and you can see if you agree with me that it's very interesting to look at this phenomenon using Treebanks. Then I also did some work in nominal sentences in some prose authors, and what I'd like to do right now is to study the syntax of the different characters in Sophocles, but I will not talk too much about that. So let's take one example to illustrate in a nutshell what this work of doing linguistic research using a Treebank is, using this study that I mentioned on the agreement patterns with coordinated subject. Well, you start with a problem, and what you do is asking Treebanks to just turn out examples, turned out data, turned out results that have the same syntactic structure as the one that you I mean the same syntactic structure that conform to a specific pattern that is illustrated, for example, in this sentence from Sophocles over here. So in the annotation style of the Treebank that we are using, that a coordinating conjunction and is governing two words as subjects, and these two subjects are subjects of a verb, and this verb has a peculiar number feature associated with it. In this case, it's a dual. It might have been a plural, or it might have been a singular. So you take a syntactic structure that links different tokens in a Treebank, and you want to extract some features that is also recorded in the Treebank about that. In this case, the number of the verb. So this is really, in a nutshell, how you collect your data, and then obviously you start with the second phase, which I will not touch today, which is the analysis that includes a lot of different other aspects. So the very first step that you want to take in this when you start is choosing your data set. So what Treebank do you use? As I said, there are a few of them, even for Greek or Latin. So last time, Vanessa and Paulina illustrated some of one of the available standards and Treebanks, the one produced by the Perseus project, ancient Greek and Latin dependency tree bank that it's supported by this tool Aretusa that was showed for the annotation. Let me name just a couple of them that are important. One of them is based in Oslo. It's the Prowler project, and it started as a parallel tree bank of Indo-European languages using the text that it's available for all those languages, which is the New Testament in different translation. And then they also added for each language some prose text for comparison. In Greek, for example, they used Herodotus and a Byzantine author. In Latin, they added some text from Caesar, from Cicero, and other late antique authors. And keep in mind that those projects, like in the link at the bottom of this slide, these projects may have different tools for querying their data available for the users. And also, another important thing to keep in mind is that each project may implement very specific guidelines and style of annotation that treat syntactic structure in a way that may be similar to the one that Vanessa Gorman showed in the last session, or they may not. In this case, it's similar but not quite identical. If you're interested in Latin, and particularly medieval Latin, I may mention also the Index Domesticus tree bank that collects works, the Latin works of Thomas Aquinas, so 13th century authors, philosopher, and it's about 350,000 tokens, so not bad. And it has almost the same tag set and guidelines as Perseus. I say almost because there are a few trivial differences. You might notice in this image over here on the left that the arbor is not SBJ as in Perseus, but SB to mark the subject. So that's a minor difference, but you must keep that in mind. And also the syntactic relations in Perseus are all caps. Over here is just title cap. And the Index Domesticus Treebanks does not offer a specific query interface, but it can be used, but it can be queried using the PML-TQ infrastructure that is managed by the Prague Faculty of Mathematics and Linguistics. I also may mention a very important project, which is universal dependencies. Oh, by the way, I should mention the fact also that for Prowler that Professor Dag Haug, which is the general manager of this Prowler project, presented something even in Sunoikisis about Prowler and how to query Prowler. So it's in, if I remember correctly, it's in the winter semester of 17-18. We did also a shared session. Universal dependencies, which was presented in Sunoikisis, if I remember correctly, last year by Marco Passarotti, is a set of unified guidelines for syntactic annotation that harmonizes tree banks for more than 70 languages, ancient and modern, especially modern, but not just. It's a very active and growing community, and it also implements some effort to go beyond, to introduce other information apart from syntax. It offers a lot of tools and software that are developed by the community, and also for querying, and also infrastructure. The PML-TQ infrastructure that I was mentioned before is also available for querying universal dependencies tree bank. And there are the major tree banks like the Perseus tree bank, Prowler tree bank, and the Index Domesticus tree bank that I mentioned before for Greek and Latin also have an export conversion to that work or may not work. You should check out for yourself for universal dependencies. Then, once you have decided that, for example, you need to make comparison tree bank, so you probably universal dependencies is the tree bank you want to query, or maybe you're interested to an author that it's also available, that is only available in the ancient Greek dependency tree banks. You should try and state and formulate your research question as clearly as possible. Let's take one example that it's not the one that we mentioned before, like the one on the agreement pattern. First comes out of the top of my head. What are the most frequent subjects of verbs composed with the preverb soon? Sometimes in Homer written as soon, or in Attic tragedy, that are found in Homer? That is a question. So again, here is one example of a syntax that is tree-banked and shows the feature that we are interested in. So a verb that starts with a certain sequence of letters and as a subject. And we may look for other example that display the same structure. So the very important thing, before you hit your keyboard and start to write your query for whatever tool you're using, the most important step you must take is formalize your query as much as possible. So what are you looking for? In this case, you're looking for a verb. So you're looking into this morphology part of the annotation to say that something as part of speech verb. This verb must start with letters, with a certain sequence of letters, sigma, epsilon, ni. And this verb must, in the dependency structure, govern at least one word as a subject. And we want to extract that subject and count them, classify them and count them. So this is important also, because you also must specify, not just interested in looking for something, but you must also know what you want to do with the results, right? Count them in this case. Group them lexically and count them. So to say that, for example, I don't know, aner, man, is there like 15 times. I just gave a completely random number. Step number 2 and number 4 are less trivial than you imagined, because we already saw that the soon part may or may not start with sigma or xi, and ni changes if it follows by to mu, if it's followed by other letters. So that string will very soon change to something else, and that something else, I know that you already had lessons about that, is a regular expression, obviously. And also want to extract its subjects, want to count what? Forms. Most likely you want, if you're doing a lexical research, you don't want to see the accusative counted as one, the accusative of aner counted as one, and then the nominative counted as another one, but you want to group them all together. So you must likely want to count lemmas. So again, this is the type of steps that you must take and clarify within your head before you hit the input in your keyboards for your query string. So I propose, in this very sense, I propose an exercise for you that is also written in the wiki of the Sunoikisis session. So in ancient Greek, neuter plural subjects can trigger, again, plural or singular agreement. This is an old feature of probably an archaism of syntax. How frequently does it happen? Which one is more frequent, singular or plural? What about the difference between two authors, like Homer and we can throw in also Hesiod or Aeschylus. And later on, I will show you one tool that will allow you to at least experiment with something like that. Thirdly, and finally, you must do your query. But first, you must familiarize with the tool, with the software, and the language it supports to perform those queries. Now, every tool is peculiar, and as I said, it depends also on the format of your tree bank and which one of those tools that are available are ready to be to support your data. And sometimes you might be, especially if you're using universal dependencies, you might be lucky, and there are a lot of them. In most cases, there is none of them, and you find a way around it. But here is a list of options that might be supported, and that can change the way you formalize your research question and your query. See if for example, if the tools you're looking for supports unlimited nesting of tree. So a noun that governs an adjective that also governs a noun that governs an adjective that governs another adjective that governs another adjective. And
we seem to have briefly lost Francesco.
So on.
Francesco, are you back? No. Maybe while we're waiting for him to come back, maybe Toon, you could start with your part.
Okay, that's great. Hello. So my name is Toon van Hal. I'm teaching ancient Greek at KU Leuven in Belgium, and I'll present you a joint presentation together with Alec Keersmakers. Here are my or our slides. I hope you can see them. Alec
Yep.
Keersmakers finishing right now his PhD dissertation. So automating the linguistic analysis of ancient Greek. So what are we going to do? We are trying to answer three questions. The first of which is, what are the starting points of automated analysis and what's the connection with this course? Then we'll present you how we can generate such automated tree banks. And then finally, and maybe that's the most interesting part, what can we do with such um, automatically generated tree banks? And that's, I think, a very interesting question because the tree banks will be generated in an automatic way, and that means that they are inherently imperfect. They will never reach 100% accuracy. So let's start with the first part. This is a course about how and why using tree banks, and Francesco was showing you um, how manually generated tree banks can be used to come to a better understanding of ancient Greek. But manually made tree banks can also be used to create more tree banks, and that's what this part is about. The data of these tree banks that have been created on a manual basis, they are used as example data or training material from which machines can learn. In other words, we are making of present day technology, and this implies the use of some, or what I could style, buzzwords such as machine learning, artificial intelligence, neural networks, natural language processing, and so on. But our focus is not very much on the development of such software. Instead, we want to make use of it by combining software, by um, manipulating the data. This is very important. So the focus is very much on the ancient Greek data. So we'll start with training data, with gold data, as it's sometimes called, meaning good example material for machines, and good example materials are man-made and manually checked. So a basic starting point is integrating and collecting all existing tree banks, dependency tree banks. That's important. So we are focusing on dependency tree banks and not on constituent tree banks. We are storing all these materials in a database, and I'll show you a screenshot of this database in a minute or so. So this is a more or less actual visualization of all tree banks that are right now available to us. And as you can see, Vanessa Gorman is the big champion of creating tree banks with more than 500 tokens or so. But the quantity is important, But not only the quantity is important, also quality is of course important. If um, there are some consistent errors in the tree banks, then the machine model will also produce errors. That's doesn't come as a surprise. And maybe more relevant than downright errors is the homogeneity of the data, because there are slight differences in annotating, and there are some different ways of annotating similar constructions, and it's difficult to say whether one annotation is wrong and the other is right. There are simply more possibilities, but for a machine learning model, it's much better if the data are um, um, annotated in one way. So this is why our work also focuses on um, correcting or smoothing a number of inconsistencies. And in the data bank or in the database I just mentioned, it's just a back office environment made in FileMaker. We try to um, automatically detect or semi-automatically detect such errors. So this is just a screenshot from our back office, and in the so you can see on the right that there is kind of a warning sign that something might be wrong with this specific token. And a last important starting point is the fact that the training data uh, should be easy to process for a computer. We all know that Greek is very difficult with respect to, for instance, ellipsis. There are many verbs, especially the copula, which isn't expressed always in Greek as we would expect it. And that's a very difficult uh, point, of course. And another issue, which is more easy for us as human beings, is coordination. And coordination, trivial example sentence in English would be he ate big burgers and sandwiches. Um, well, it's about n structures. But as you will notice, this is about what I could style horizontal elements. But these elements, which are um, horizontal, are very difficult to represent in a rather vertical tree structure. So one of the challenges is finding workarounds in our back office environment, so that we can manipulate the data in such a way that they become more digestible for computers. Step number two consists in creating a pipeline. So what's a natural language processing pipeline? This is just the design of a process where the output of a certain module feeds to the input of another module, B, for instance, whose output feeds to the input of module C, etc., and so on and so on. So let's have one example sentence. It's sentence I found in Goodwin's syntax. Kai tut ipoiun heos ekteis horas apein. It's a sentence. Okay, what can we do with that? So first of all, we can tokenize it. Tokenization is the process which or the process of converting a string of written language into a sequence of uh, separate tokens. And most of these tokens are words, but also interpunction is involved in here. This process is rule-based, and I will go to the next steps because they are more interesting. A second step consists in part of speech tagging, which is a process of assigning each word or each token in the text a specific part of speech tag. So, for instance, in this case, we have horas. Well, that's a noun and it has also some attributes, genitive, singular, feminine. In order to come to automated results, we make use of technology. And in this case, Alec did all the work and he made use of a certain tagger, RFT tagger or RF tagger. And of course, it's much more than just applying the tagger. There are also many pre-processing steps involved, but I cannot go into details in this respect. The accuracy is quite high for this step, so from 90% to 96%, more or less. Um, we will see in the exercise or in the second exercise that there are some, let's say, challenging constructions that are prone to be annotated in the wrong way. The following step consists in lemmatizing. This is also quite straightforward. So in this step, each token is assigned a specific lemma, so basically a dictionary entry. Marmot is used in this process. That's a certain technological tool, and which is very important to mention here is that some of these tools allow us to integrate existing dictionaries, and the tools allowing us to do so, they of course will lead to better results. As you can see, the results here are quite good. Step number 4, that's the parsing part. What are we doing here? Well, we try to come to a, 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 an automated syntactic tree, as you can see on the right hand side. So the trees you've been making during last session can also be generated by a computer. So basically, this consists in assigning and defining relations such as adverbials, objects, etc., and also the right heads. We used parser in the first tests, but since, well, let's say for 5 months or so, we are making use of a neural parser made in Turku, um, offering us much better results. It's very difficult to assess um, parsing results, and one reason is that they are highly dependent on the author analyzed. For instance, Aristotle is a very, it's not a complex author. He's making use of rather short sentences, but we see that the results are quite bad. Whereas, for instance, Xenophon or Lysias, the results of their texts are much better. And then a final stage, which is often absent from manual tree banking work, is semantic annotation. And Alec is exploring the possibilities of semantic annotation right now, both on the word level. This implies the use of word vectors, and I will not go into details here, but word vectors, using them allows us to find, for instance, synonyms. So the um, the computer will feel to a certain extent that they, the word they, is connected to some extent to the word year, month, etc. And we can also define semantic roles. So in this example, for instance, horas indicates the source from which the person discussed in the sentence is coming. It is important to highlight that the very concept of pipeline implies a process of subsequent steps, but it's relevant to underline that the information, for instance, coming from the last step, the semantic step, might be also very fruitful for one of the first steps. So, in other words, in future work, we hope to make better models by benefiting from cross-breeding effects between these different steps, undermining to some extent the idea of a very severe pipeline in which the sequence is quite fixed. Last part, what can we do with all this information or with these data generated by a computer? So we can come to an automatic analysis of the Greek literary corpus, but also of the papyrus corpus. Then we can speed up manual annotation by correcting pre-processed data. And that's the way we are making Treebanks right now in our Leuven group. So it will not come as a surprise that this automatically analyzed data is highly relevant for linguists because they can do the right or the same thing Francesco just demonstrated, but on a much larger scale. Of course, it's very important to keep in mind that all annotations that are automatically generated are inherently imperfect. So they should be checked uh, they should be checked, of course, and they can never be taken without controlling them. That's of course no surprise. But also for historical questions, these automated tree banks can be useful. For instance, historical data from the papyrus corpus can be processed by making use of certain collocations um, which can which can occur in the data, and also conceptual or intellectual history can benefit very much from a large corpus of automatically generated data. Here in Leuven right now, we are exploring the results of these automated tree banks, um, especially for didactic aims. So we are currently in the ongoing Pedalion project, making word lists, intensive courses for students without prior knowledge of Greek, and also making reading commentaries. So for instance, our ongoing Helia project is a list of 1000 keywords of ancient Greek. They're corpus based, and this is pedagogical material for pupils in high schools, but also for our university students without previous knowledge of Greek. And every word which is present in the Helia list is illustrated with an authentic sentence, which in its turn also contains only words coming from this Helia list. I think this is about it. Of course, we are also creating new tree banks. Yes, Gabby, the floor is yours.
Okay, thanks, Tom. We were about to go back to Francesco, but he seems to have had a network problem again. So we may need to wait for him to come back for that. We'll keep an eye on the bottom left video and see if he reappears in there at some point. So apologies for for that. He says he's going to try and move to another venue and see if that's better. Should we maybe start with a bit of discussion of this then, as we were midway through as that, and we were going to talk a little bit about that. So one thing we could do is we could ask Alec to maybe say a few words about what specifically he's researching by way of doing this, or I mean, I'm interested, for example, in asking what philological questions you're asking that led you to do this sort of research. But if there's any other aspect of your research you'd like to briefly mention, then please do.
Yes, so I'm currently working on the papyrus corpus, so non-literary texts, and I'm studying complement structures, so aspects mostly in complementation structures. And the way I'm using my automatic results right now is, first of all, to more easily retrieve the constructions that I'm interested in, but then on the other hand, also, how do you say, look how the results can be, or how the results retrieved by the automatic parser, for instance, do match the results we want to retrieve, and what kind of problems are still lacking with this machine learning approach, and how we can improve the machine learning approach basically to better get these constructions. And then I'm doing also some classic linguistic research when I have these results, basically, if that was any clear. You're still muted.
Apologies, yeah. I thought I'd unmuted myself, but I must have remuted myself. Sorry, no, I just said yes, that was very clear. And did anyone else have any questions or anything to add? We're also joined by Chiara, who's talking about translation alignment next week or last week, depending on which time zone you're in, who may or may not have questions.
Well, maybe if that's a good suggestion, I can just show you how an annotated sentence looks like, an automatically annotated sentence looks like, and how we can correct them. And this will give the students more or less an idea of, okay, what does the parser what is the parser able to do, and what are the ongoing weaknesses the parser or the pipeline is still experiencing. So if that's okay to you, Gabby,
Yes, sure.
while we are waiting for Francesco, I'm just showing you some sentences from the fourth book of Epicurus' Discourses. So I just selected a few sentences, and some of them are quite good, and in some instances we have to make some modifications. So I'll just read the Leuven translation, and then I can discuss what's good and what's less fortunate. So when he prays for these objects. This is, of course, a very short sentence in Greek, but it's quite good, and the quality is good. And I know it because I inspected it in advance. So the euchomai, for instance, is indeed a verb, third person singular, um, and in the indicative, etc. So we have to check every single token, but once you are more experienced in doing this, it's more straightforward to detect possible issues. For instance, here it's very important to check whether Toon is neutral, because it should be neutral, but morphologically spoken, could also be um, it could also be masculine. So, but everything seems to be fine here. This is new, the semantic role, and as I said, the translation is when he prays for these objects. Um, Here we see that semantic role is indicated as being cause, but I think here we should correct it in either respect or beneficiary.
Goal.
Okay, nice. Goal in Alex's opinion, and this immediately makes clear that that defining a semantic role is also to some extent um, it's it can be discussed. Not everyone will define it in the same way. So moving on to the following sentence, I think there is a problem here too. Um, so when he sacrificed hotan tuei, he sacrificed for these objects. That's the Lloyd translation. And also here we have to change the semantic role that has been assigned in an automated way is time, but it should be goal. The rest should be quite fine. So let's go right now to an example where either the morphological information is wrong or the syntactic information is wrong. And therefore, I'm going to sentence number 10. This is a longer sentence, so I'm moving this a little bit. Legosin kai hoi philosophoi hoti uden kolue pseudos epein. So what does it say? Even the philosophers, kai hoi philosophoi, say, legusin, that there is nothing to hinder one's telling a lie. Hoti uden kolue pseudos epein. So this is quite correct. Hoi philosophoi, legusin is indeed the uh, predicate, and the entire object of legusin is, and that's entirely right, hoti uden kolue pseudos epein. So that's the object or representing the object, meaning the entire object phrase. So, but here there are some problems. So uden, for instance, is indeed the subject, but that implies that um, it should be nominative, whereas it is accusative here. So we have to change that. And on the other hand, so there's nothing to hinder one's telling a lie. this should be, at least in my opinion, the object of colue, of to hinder. So there, the morphological part is okay, but we have to change the tag of the relation into object. Pseudos is indeed an object with a pane. There we always have to check, because that's some of the challenging and thorny issues. We have to check with neutral nominatives or accusatives. We have to make sure that the label is good, and it is indeed accusative, so that's fine. And to illustrate this this principle, I'll show you a last example. A very simple sentence, and we would expect that there would be no problems here. But if we have a look at zoion, I'll first translate the sentence. I am Amy, logikon zoion, a rational creature. We would expect that this is a nominative. And what do we see? It has been tagged as an accusative. So we have to correct this. And then the same goes for logikon. We see that the relation is in order, and the same goes for zoion, because it is the nominal part of the predicate. So this is an attribute, and it will be also labeled as an accusative, and we should change this. So this is a very short demonstration of our way of proceeding, and it also shows us how we can come to better results in the future. As you can see, the relation in this example was in order, it was correct, and nevertheless, the morphological part was wrong. And if we succeed in designing a model where the morphological part can be corrected on the basis of the syntactic information, such errors could be prevented in the future. I hope this was clear to you, Gabby. I can show you, of course, other information or other sentences, but maybe this is enough for having an idea. It can also be added that that tree bankers in the world interested in making tree banks based on the pre-processed information we can create, you're very welcome to contact us so that we can provide our colleagues with these pre-processed information. We can also be honest. So if it's Aristotle, for instance, we can give you the information, but we cannot promise that you can do much with this data in contrast with, for instance, this information coming from Epicurus or other authors.
Great, thank you, Toon. That was really useful. I think we have Francesco back now. Yes, looks like it. So, yep. So, Francesco, would you like to come back and move on to your
Sure.
your demo of searching Treebank that you were going to give very briefly?
Okay. So what I was saying is that what you want to check in your tools, because most query languages support can be query tools can be more or less sophisticated. And there are a couple of things to look for. As I said, you might want to look for tools that support the nesting of many sequence of the dog of the nation, that's you might want to check if also word order based queries, so queries that can also let you that let you also specify the constraint that the adjective must precede or follow the noun. If it supports negative queries, so all noun that do not govern any adjective at all, if they have a graphical user interface that allow you to query graphically, if they support operators such as and or, so you can specify if you want more than one constraint or one constraint and not the other, etc. And then talking about the output, if they support mathematical operation on your output, so count the results, let you do some means, for example, on the output, and other thing also, the kind of output that it gives. So if supports, if it also lets you visualize the trees, or if it lets you export them in text format, in tabular format, in JSON, HTML, etc. So for the second part of my presentation, I wanted to show you this in practice with one example. So the example I want to show you is this tool, structurable online, www, which is, I think it's interesting because it supports the query on the Treebanks of Greek. In some of the text that was Treebanked for the ancient bank that you saw in Vanessa Gorman's presentation. Not all of them, unfortunately, but some texts are supported, and we'll see in a second which ones. It's very simple, but it's full. It's very quick and allows some sophisticated query, but don't support some of the features that I listed before. But it's still an interesting approach to how to do the kind of exercise that I mentioned before. Its system, it's actually very ingenious. It's based on the CSS selector, the type of things that power also the web pages that you see around in and on that type of syntax. So let's see this to the some sort of a web presentation. So as I said, this is the web address, iliados.com, and as you see, it supports quite a few texts, not many of them, and not those prose texts that Vanessa Gorman Treebanked and presented before. Not yet. It's a bit old, to tell you the truth, and I don't know if it's still maintained actively or not. But it's good for exercise.
Is it possible to zoom in a little bit on this?
Of course, I can still zoom in.
Lovely, thank you.
Then tell me about the output, of course. So right now, let's do some exercise on the Iliad and the Odyssey. So the first interesting thing that you can do with this is just start with a very easy lexical search. So right, you can write a word and just to familiarize in what we got. As you saw, so we looked for the manis, like the very first word in the Iliad, the wrath. The famous wrath of Achilles is defined like that, with this word. Only in the Iliad and the Odyssey, and it starts with the Odyssey for the results. And as you see, the results are, what you get is the sentence where a match is. Sentence from period to period. So it can be quite long, and it can be, tell you the truth, a bit unnerving to just find out where your word is. Here, for example. And as you see, it's it's not the form. So manin, the accusative over here, is found because it was looking for. And as you got a cool visualization of the dependency structure of a word like that. And if you click over here, you go to you go to visualize the passage on Perseus so that you can do more research on that. But that's a limitation, to tell you the truth, because you don't immediately find the words or the structure that you're looking for highlighted in the text for you. So some and this is especially tricky whenever you utilize, of course, the coolest feature in a tree bank. So when it gets interesting, so when you can use grammatical features to search for. So if you want all noun, for instance, you can do something like that, right? You can use what is called selector, right, which is preceded by this this semicolon over here, and down to look for all the attribute that you want to. Over here, for example, okay, it's very quick, you results, and there's a result count. But then again, it gets. I assume this counts as one big result, which is not repeated, as you said. Even if these sentences are likely many nouns, like many in the wrath of Achilles, etc., etc., Algead, pains, etc., etc. So this is and you don't see them at all over here. So you just have to quickly go through all the words to see, this is a match, this is a match. But then again, you can change of this pseudo selector as you want. Here, for example, we look for noun accusative singular. Obviously, again, we have this passage because over here we have a fantastic noun accusative singular, manin, the wrath, which is an accusative. Alternatively, you can directly use a selector to investigate exactly the type of attribute token that you wanted to. Like, for example, if you want the exact form that is found in the text, and you really want this accusative form manin, here you go. You can click and have less results over here. And obviously, you find Iliad 1 and many other passages. By the way, the same query we could have done that also using the pseudo selector as before. So, for example, we use manis and accusative. So we select the word that we want and we attach a pseudo selector to it. Same results. That again you can study and visualize.
In theory, presumably that would have also found accusative plurals.
That would have also found accusative plurals, exactly. If you want to just limit to the singular, you can do like that. And you can see it's very fast for that. So it's an interesting exercise to familiarize with the syntax. Oh, by the way, another reason why I like this is because it's very clear. The documentation is very well written. It's full of examples and dynamic example. More meaning that you can click on the queries and perform them, and so I really invite you to follow this link and visualize the documentation. So how do you query the syntax with that? Easiest thing is use a selector again to query everything that has a syntactic relation. For example, the syntactic relation atre that is used to mark the adjective referring to a noun or the articles, or the genitive. So everything that has an atre over here, yes, we can relation equal atre. It's written like that, and that should return everything that has that relation. Yes, in this very long sentence, there is something that has this relation. We can see it. No, the relations are not reported, but I can tell you for sure this is the relations that it's that is also marked. So Muria over here with alges, it would be the same, and so on. This is a very trivial way. Now we have learned anyway how to query for manis, for all the instances of the word manis, and we also learn how to query for everything that that has the relation, the syntactic relation atr. Now let's combine the thing. How you do that? Well, you use this greater than operator. So like that, you can. Oops, sorry. You can write this query over here, and that will look for everything. So every instance of the word manis that governs something, a node which has the relation attribute attached to it. So not art, because it will not find anything, but atr over here. And that will return again some results. Over here, for example, you can see that this theon goes with manis, and it's exactly the type of match that it's this
Sounds like we're losing Francesco a little bit again.
Oh, can you hear me now?
We can, yeah.
Oh, good. Okay, good. So let's go back to the. So again, this man in Dios, the wrath of Zeus. So again, I will not go into all the details. Now we can also, interestingly, obviously, we can break it down. So as I said, this atr relation covers genitive and adjectives. So let's analyze them one by one. So adjectives over here. So again, a word that governs something that is pseudo selector, it's an adjective. I don't know if it's clear, but it should be. OLOS, again, it's with manis, and it's good. So manin, ulomenen, okay, the wrath of Achilles over here. So it makes this other results from the Iliad book 13, and it's Calepen. Calepen. The other option would be any governing some specific that this genitive must have the relation atr. Doesn't hurt. We got 12 results. So the wrath of the gods, that is good. And yes, again, this manis that these are the results that we've got from the other places. The manis with an adjective. It's as also genitive over here. So it's a second match again. So and then you can look for all the other results. See the wrath of Apollos. Oh, by the way, we find this this match over here with the Calepe, but we didn't find it before. Why would that be? So I at the error in somewhere, either from the query software or the annotation, but in fact the annotation is correct, because this Calepe, this hard, it's not an adjective that goes with manis, but it's the sentence is a nominal one. So the wrath of the god is, and it says an attribute. So it should very likely be annotated like that. So this is depending on the coordinating conjunction as per the guideline of the ancient Greek dependency tree bank. So it's good that this sentence did not show up in our query before. It reflects the annotation correctly, because as you see, this does not depend on manis. So does Iliados support word order based queries? It does, actually, and pretty brilliantly. So you can use other pseudo selectors. So for example, you can look for cases where manis is followed by something that has a relation, and you can look for it. So you can use the two pseudo selectors, specific pseudo selector, after and before. So in this case, for example, no, it comes after the relation. So sometimes it's a bit query. It's a bit tricky to remember the exact meaning of this. Is that it's that in the parentheses of after, what the scope is what comes after what we are using the pseudo selector on, or the other way around. Obviously, it's as you see in this case, obviously we have the first line of the Iliad, because manin is very first word in emphatic position, and then the adjective that refers to it, ulumenen, comes after that. So in this way you can query combine word or and it's use it for this type of query. Does this tool here support regular expression, as we said before, so that we could do this query that I mentioned before, like the one where we are looking for sum compounds in and all the subjects of those verbs? Unfortunately, not. Not that I could do a few version. Know that as selectors at one point support regular, at least in this version, and not all the syntactic construction do not work here in Iliados. So that it's actually a query like the one that we mentioned in the slides is not possible in this using this interface. But still, there are a few things that, as you said, you can do, and you can start familiarize with this. Obviously, much more carefully than I did in this very quick demonstration, simple demonstration, is check your output very carefully, because you really want to know whether your matches are correct matches. Sometimes the error might stem from either your bad interpretation of the sentence, like in the example of the Iliad file that I showed before, or in some problems with annotation. That happens. I mean, all humans are not perfect, and we leave annotation errors around. So if you spot some, then you must take notice of that. Or this is less likely, but this tool was a very experimental approach. It might even be that there is something not working or not working very clearly in the tool. Let me show you one example of that. So, for example, I did some queries also on the verb aedo, to sing. See, for the lemma. Okay, let's limit ourselves to the Then we see, okay, I wanted to see something that that governed a noun, whatever reasons. First I had 8 results, now I have 9 results. But actually, if you count them, they are really 6. There are really 6 results. So I don't know exactly what comes over here in this number, and they look correct, at least to me, because the 2 that are missing, so 8 in total, 6 when Aedo is governing a noun, are just example of sentences where Aedo does not govern anything, or and of course any noun. So they look correct. They shouldn't be there, and they're not there. And there is no 9th result that is added magically in the process. So I don't know exactly why this number came out. So again, do not trust too much, especially if you're writing a dissertation or an article or a conference. To trust your tools too much. Never. That being said, okay, one last thing from my requirements remains to show: does it support continuous complicated nesting of dependencies? Well, let's try one. Noun governing a noun governing a noun over here, this query. That worked. So you see, for example, here, the cows of the sun. So you see, that worked.
Great. I'm not sure if Francesco just finished or if his audio broke again, but either way, it sounds like you were about done there. Yeah.
Yeah.
Yeah. Okay.
Can you hear me now?
Yes, we can. Yeah, you're back. Yeah.
I'm very sorry for this connection, but unfortunately, that's not in my power.
These things happen. Yeah. Sure.
And but anyway, yes, this is a short overview of the tool, but I think
absolutely.
One last thing maybe that I mentioned back to is the fact. Oops, why it's starting from us? Okay. One last thing that I wanted to. Okay, over here. Especially in the part, you remember I said that you also must be clear on what you want to do with the results. If you want to count them, what type of operations you want to do with your output and everything. And obviously here a whole world opens to you, that is the one of quantitative approach to research. We don't have obviously the time to touch on any aspect of this very complicated subject. I would really recommend, in these slides, you see the cover of this book by Stefan Gries, which is advertised as a book on introduction to the statistical environment R, but it's much more than that, because it had very interesting chapters about how to do quantitative researches and experiments in linguistics, and especially tailored for linguistic studies. So that's includes what I wanted to say.
Great, thank you, Francesco. That's a very useful pointer there as well. We've students have already in this semester seen some examples of using Python to do visualization and so forth in a very general way, and they will have seen last week, by the time they watch this, some more examples of Python being used to query translation alignments and things, which will be quite interesting, I think, to create automated translation alignments. So it's, and we did talk, I think, in last year in a similar session to this, we talked specifically about using R to query treebanks. Bob Gorman came along and gave us a presentation on that, so that was quite interesting. So there has been one question asked on YouTube, which is about getting access to the Aristotle and Herodotus treebanks. I don't know if anybody wanted to quickly address that.
Yeah, well, I can quickly address it. So, in general, we want to share our we want to share all data we created. As for Aristotle, as Tom mentioned, quality will probably not be that high. The main reason is that's very elliptic. So, of course, it's difficult for an automatic parser not only to determine the relations between words, but also to insert words that aren't even there in the sentence. So that's the main reason. As for Herodotus, there is already quite a lot of Herodotus data in the ProIEL tree banks, which is manually annotated. So I would have a look at this data first, because the quality will, of course, be a lot higher than automatically automatically parsed version. But in general, if you want to have some data we automatically parse, you can always contact us and then we can see.
Right, and since Osama said he's very interested in the Aristotelian corpus and in particular the Poetics and treatises like that, if he's interested in those, he may also be interested in improving your automated tree banks,
sure, that would be great.
That would feed back into that. Yeah. I mean, I can't speak for him, but it sounds like the sort of thing he might use with students, or he might, and that could be useful on both sides. Yeah.
Okay.
Yeah. Great. Well, I can put you in touch with Osama. I don't know if he's still watching now. He hasn't commented for a few minutes, but if he is,
okay.
Yeah, put you in touch.
Okay. I'll have to leave now. So.
Okay. Thank you for joining us, Alan.
Yeah.
Was there anything else in the schedule that we haven't covered yet? Toon, were you going to say anything more about the second exercise, about the correction exercise, or is that what you talked about already?
Well, I think I told you most of it. So I hope I was able to demonstrate how we work or how our way of proceeding is. Basically, it's quite easy in that we can just correct uh, things that are wrong and concentrate on the most challenging points. There is one disadvantage, of course, and that is that some solutions might seem correct or might have a very good have y- or yeah so some of them they seem to be correct but they aren't and that's the tricky thing, of course. So the the general good results or the general quality might also make us a little bit too lazy, and so that there are some errors which remain there, and that's, I think, one of the things which should be taken into account. um,
Is
of
this a
course.
particular hazard of using machine learning to do these things, which is that they will, because they're doing this from observation of, and ingesting many, many other examples, they are likely to provide annotations that look convincing because they're similar to other annotations that have existed, even if the grammatical feature they come across is actually quite unusual and should be something different. So at first glance, it would look quite convincing.
Mhm. Um, well, that's possible, but I cannot answer that for sure right now. There is another, but I can tell you this. I do think that we can make use of machine learning techniques in order to do some anomaly detection. Um, so once we've got the data, and once we have manually annotated tree banks in our database, um, we have some rule-based procedures in order to detect anomalies. but I think it's also possible to do part of the anomaly detection by making use of machine learning techniques. So I think you're right. I think that machine learning techniques can create solutions that might prove to be convincing, but in the end they are erroneous. I wouldn't exclude that, but on the other hand, I also think that we can make use of machine learning techniques, that we can benefit from them, in that also anomaly detection, even in completely uh, manually annotated tree banks, can lead to better uh, results.
And I guess the final question, and apologies if I missed this when you were talking, as I was also trying to juggle with the network problems we were having. Did if a student wanted to get hold of some of your automatically annotated tree banks and try and correct them as an experiment to see how that looked, where would they find that? How could they do that?
Well, right now we haven't published the corpus ALEC annotated. I think it's a corpus of about 4 million or 40 million. I know it's a huge difference, but it's difficult for me to process it anyhow.
They're both
Um,
unimaginable numbers. Yeah.
yes, so but it's a huge corpus, and he's planning to publish it, but right now it isn't available yet. But what we are doing right now is sending and making available particular texts for scholars and colleagues interested in these particular texts, and then we're just providing it via email exchange, because I really have to underline that Alec is currently in the last stages of writing the PhD. So that must be prioritized. And after that, we can think of making this available in a more in a less clumsy way, so to speak. But right now, um, um, it's just about writing an email so that we can send the materials.
Would it be possible for you to maybe upload just a small handful of sentences to Arethusa, as you did in the demonstration,
Of
and include a
course,
link to that, so we could at least look at that
of
and have a
course.
look at, yeah.
That's no problem, and I can make use of the sentences I just made use of,
Perfect.
and I can add much more material. That's no problem. And maybe one last thing I can add is the fact that of course, just to make sure that everything could be seen on the screen, I limited the examples to simple sentences. But of course, complex sentences are more difficult than simple sentences, also for computers, that's for sure. But what we see is that even though errors are made, of course, in long sentences, that huge parts of it are correct, and um, that 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 important building blocks of long sentences are correct, and that's the reason why this automatically annotated corpus could prove to be very helpful for historians or even intellectual historians right now, rather than for linguists, if and provided that these linguists are only interested in completely reliable sentences. So I think that's also an interesting aspect of this automatic annotation, of course, it's far from perfect, but it also challenges us, and we are also encouraged to be creative in things we can undertake by relying on this new annotations. And of course, we would be very happy to come to much better results in the future, but it's my basic conviction that the data as they are right now can already be helpful for several applications.
Great, thank you. Yeah, no, I'm sure they can. Okay, so to summarize, then there are two exercises following from this. The one more immediate exercise, which is to try and answer the question that Francesco gave us using the Iliados search tool, and then the second is for people who feel a little bit more confident to take a look at some of the automatically parsed sentences that we will provide a link to on the session page shortly. And have a go at correcting those, or at least looking at those and trying to find problems with those. So that's wonderful. Thank you both very much for the presentation. Despite the technical difficulties, I think it went brilliantly. I was very pleased with it all. Does anyone have any final comments they want to make, or questions for each other? You're still
quick note. Can you hear me now?
Yes, I can hear you. Yeah,
okay.
Yeah.
Now, one very quick note. If you're interested to go beyond the limitations that I showed before, well, I can just recommend a couple of things. There are a few in the past. There were a few about querying Treebanks using more sophisticated methods. One by Giuseppe Cellano on going directly on the source file using a language to query XML. It's definitely recommendable. I gave a query. I gave a class a couple of semesters ago on querying on transforming the format of the Greek Treebank and Greek and Latin Treebanks in order to use tools that were made for other formats like universal dependencies. And in case, just get in touch and I can help you with this type of tasks.
Right. And we could maybe put a links to a couple of examples of that on the session page as well. Another example is that Paulina, who spoke in the previous session, she puts the XML of her Treebanks into the XML publishing system Kiln that the Epidot publishing tool FS is based on, and then uses that native querying and indexing features of that to search for linguistic features. So that's something else we could point to. Yeah. Great.
Okay.
Thank you.
Thank you both
Toon,
very much.
Were you trying to say something a minute ago?
No, just thank you for the opportunity, and yes.
Cool. Well, thank you both very much. And I've lost track of which is the next session and which is the previous session because these are out of sequence. So I won't say join us again. Well, do join us next week, but I won't say what next week is because I've confused myself and forgotten. But thank you both very much, and we'll speak to you again. Cheers.
Cheers.